This example comes out of section 2.3, Sum and Difference Rules. Up to this point we've found derivatives of relatively straightforward functions. Y equals, 15x cubed. Well, the derivative of that is going to be 45x squared. Question is, what happens when you start to get other things added and subtracted in there? Like if I have, for example, y equals 15x cubed minus 7x squared plus 11x plus 43. Turns out that the answer to that is real easy. You take each of these derivatives separately, and so this first one we already said was 45x squared. The next one is going to be 14x. The next one is 11, and the derivative of a constant is 0. So the derivative of that big cubic function turns out to be this slightly smaller, simpler quadratic function. But basically the rule as it's stated in a few different formats is if you have f plus g and you're asked to take the derivative of that, you can just do the derivative of f plus the derivative of g. If I'm saying the derivative in this format of f of x plus g of x by dx, it equals f prime x plus g prime of x. And the same is true for minus. If I put a minus there, plus minus, plus minus, plus minus. So, for example, if we do another example of this, if we have f of x equals 3x to the fifth minus the square root of x. Well, I don't really like radicals. I'm going to write that as a power, x to the 1/2. The derivative of this is going to be the derivative of 3x to the fifth, which is 15x to the fourth, and then the derivative of x to the 1/2, which is, so I have minus 1/2 x to the negative 1/2. And if we had to do something further with that, we might have to factor or simplify it in some other way, but as far as what we're doing here, that's as far as we need to go. Now, a slightly more, I suppose, complicated example is if we're asked to differentiate y equals x minus 2 over root x in brackets squared. Later on we're going to come up with some rules for taking derivatives when there's a function inside a bracket, something else happening to it, whatever. But for now we don't have any of those rules, so what we have to do is expand this thing and say, well, x minus 2 over root x times x minus 2 over root x. I can multiply those together, FOIL it, x times x is x squared. I'll get minus 2x over root x minus 2x over root x plus 4 over x. So if I keep simplifying, I've got x squared. This is going to be minus 4 root x and then plus 4 over x. If you're having trouble with how x over root x equals, so it's x to the 1 over x to the 1/2, subtract the exponents, you get x to the 1/2. So the derivative of this, dy by dx, or y prime, however you prefer to write it, is going to be 2x minus, now 4 times 1/2 is 2, x to the negative 1/2, and then minus 4x to the negative 2. So the power rule and the sum and difference rules combine to be pretty powerful to save you incredible amounts of work in terms of finding derivatives of more and more and more complicated functions.